In this video, we'll do the integral of x to the fourth times x minus 1 all raised to the fourth all over x squared plus 1 from 0 to 1. Also, don't forget to subscribe and turn notifications so you don't miss a video. Okay, this integral is pretty special, but we'll get there later. Okay, so this looks really hard because we have x squared plus 1 on the denominator. On the numerator, we have an x minus 1 all raised to the fourth. So let's look at that. So x minus 1 all raised to the fourth. So the binomial coefficients for this case will be 1, 4, 6, 4, 1. Because the Pascal's triangle, it's 1, 1, 1, 1, 2, 1, 1, 3, 3, 1. And you just add the terms. So 1 plus 3 is 4, 3 plus 3 is 6, and 3 plus 1 is 4 again. And then 1 stays the same. So this will be x to the fourth. The negative 1 will change. So this will be minus 4x cubed plus 6x squared minus 4x plus 1. Okay, now we're going to multiply that by x to the fourth. So we have this multiplied by x to the fourth. So this will be x to the eighth because we add the terms, the exponents, minus 4x to the seventh plus 6x to the sixth minus 4x to the fifth plus x to the fourth. Okay, so we have this, which is the numerator of the integral. So we have minus 6x to this plus 6x to the sixth minus 4x to the fifth plus x to the fourth all over x squared plus 1. So this is really hard. So we have to do polynomial long division. So we have x to the eighth minus 4x to the seventh plus 6x to the sixth minus 4x to the fifth plus x to the fourth, all divided by x squared plus 1. So this could get pretty long. So we're going to look at the first coefficients. That'll be x squared and x to the eighth. We have to multiply x squared by x to the sixth to get x to the eighth. Now we have to multiply that back in, so that'll be x to the eighth plus x to the sixth, multiplying x squared plus 1 plus x times x squared, x to the sixth. Yeah. Then when you subtract these, we'll bring this one down. So we're going to have minus 4x to the 7. Okay. Now we're going to have plus x. So we're going to have plus 6x to the 6 minus, because we have the minus sign, x to the 6. So that will turn into 5x to the 6. Okay. So now we look at x squared plus 1. We look at negative 4x to the 7th. So we have to multiply this by negative 4x to the 5th to get negative 4x to the 7th. Okay. Rewrite that. So multiply that back into x squared plus 1. So that would be minus 4x to the 7th minus 4x to the 5th. We'll bring this term down. So this minus 4x to the 5th down. So we minus minus. And you notice that negative negative will be positive 4x to the 5th. And negative 4x to the 5th, that will cancel. Okay, good. Now this will cancel because they're opposite signs. So this will just be 5x to the 6th will just come down. And then we'll have plus x to the 4th. Because we'll just bring this down just for whatever, it doesn't matter. Okay, so now we need to multiply x squared plus 1, x squared by 5x to the 4th to get 5x to the 6th. Okay, so we multiply that back in, we get 5x to the 6th plus 5x to the 4th, and we subtract both. This will cancel opposite signs, or same sign that you negative of x to the 4th minus 5x to the 4th is minus 4x to the 4th. So we need to multiply this by minus 4x squared by x squared to get minus 4x to the 4th. Okay, we multiply that back in, so we get this. Okay, same signs, negative, so cancel. This is 0. So 0 minus minus 4x squared is just 4x squared. So net positive 4x squared. So you have to basically add 4. So 4 times x squared is 4x squared. Multiply that in, so you get 4x squared plus 4, just 4 because it's plus 1. Minus minus, this will cancel, leaving us with minus 4. So what do we do with the minus 4? Well, it's all going to be over x squared plus 1. Because that's the same denominator as before. So it's minus 4 all over x squared plus 1. So now we're going to integrate this. So this will be equal to, okay. So we're going to integrate these from 0 to 1, like so. But let's look at the integral from 0 to 1 of x to the n. This is just x to the n plus 1 using the reverse power rule over n plus 1 from 0 to 1. 0 to n plus 1 will be 0. 1 to anything is just 1, so this will just be 1 over n plus 1. And if there's an a here, there's an a here, there's an a here. So that's the form we're going to use. So we're going to have, okay, so we're going to have 1/7. Okay, we have 1/7 minus 4x, 4 over 6, sorry. And then we're going to have plus 5 over 5, which we can simplify these. And then we're going to have minus 4 over 3. And then we're going to have plus 4x from 0 to 1, that's just 4. And then finally we have minus 4. Okay, so let's look at this. The integral of 1 over x squared plus 1 is the inverse tangent of theta, or x in this case. Plugging in from 0 to 1, so this will just be inverse tangent of x from 0 to 1. The inverse tangent of 0 is 0, because tangent 0 is 0. Inverse tangent of 1 is defined to be pi over 4. So it's nice that the 4 is there, because this is 4 over pi over 4, so that's 4 times pi over 4, so that the 4's will cancel, leaving us with just pi. So we're going to have minus, so we're just going to have pi, because the 4 was there for the integral. Okay, this is be 1/7. Minus 4 over 6 can be written as minus 2 over 3. Minus 2 over 3 minus 4 over 3 is minus 6 over 3, which is minus 2. So this will be minus 2, 5 over 5 is 1, plus 4 minus pi. So this will be 1/7. Minus 2 plus 1 is minus 1, plus 4 is plus 3, minus pi. 3 can be written as 3 times 7 over 7. 3 times 7 is 21, plus 1 is 22 over 7 minus pi. So this integral is equal to 22 over 7 minus pi. That's a nice result. So let's look at the original integral for a second. So if it's x squared or any even power, it's going to be positive. So actually this is always positive. So this is bigger than 0, because x squared will turn any negative into a positive. So what we really have, which is really interesting, this integral is bigger than 0, which means we can add pi on both sides, leaving us with pi is defined to be less than 22 over 7. And that is the end of the video. Hope you liked it. And thanks for watching.